want to show you exactly what we're doing. On page 14, what we're looking at here is how I can rewrite this in a way that is going to help me manipulate the function. When I make the substitution, this will become either an inverse sine or an inverse tangent. When there's a radical, this needs to look like inverse sine. So you guys told me that the integral, the inverse sine is 1 over the square root of 1 minus x squared. Is that true? So if I make that variable a u or a k or an m, it doesn't really matter. All right. So the first problem that we're dealing with here is this is not a 1. Yes?
If this is negative, would it be...
Yes. Yeah. But if you go back to the integrals, that's not on there. Only inverse tangent, inverse sine. Guys, I'm telling you, the bottom of that page, you have to know them. Okay, so remember I said that these are ones where you just have to spit them back out. You have to know them. Okay? Yes?
I was just going to ask, could you just make that rotate to the negative 1/2 power? If you make 9 minus 4x squared u and work everything there, like, I don't understand what you're talking about inverse trig function.
But the problem here is when you make a u sub, you can't just... So if you're going to integrate, if I make that to the negative 1/2 power, the problem is I need to be able to integrate what's on the inside. The only way to integrate what's on the inside is to use u sub, because you're backing out of the chain rule. You're going backwards. Okay, this is undoing the chain rule. So the problem is that if I make that substitution based on what you said, when I take the derivative of the inside, this becomes negative 8x dx. If I make that substitution where I have u to the negative 1/2, what's the only thing I need to get rid of? A dx. I don't have an extra x. So you can't just kind of make one appear in the problem. So this is what I'm saying, and I'm going to show you 4 problems where they look almost identical, and these are little things. It's a good question. It really is a good question. You have to make sure that you don't have extra items. Here, I don't have anything extra. So that's what I'm telling you. Here, you want this to be a 1. You need this to be a term squared. Remember how I took that 25x squared and I rewrote it as 5x squared so we could make the substitution to make it a single variable? That's what we want to do. The problem is I need to get this 9 to be a 1. So the only way to do that is to factor it out, ladies. So what we have here is 1 over. This becomes the square root. Remember, when you are factoring something out, you are literally dividing by that value, right? So when you factor out a number, you are dividing by that number you're factoring out. So when I factor out a 9, I'm taking 9 divided by 9. So I'm going to put that 9 I'm factoring out right here. 9 divided by 9 is 1 minus. The problem here is this is not divisible by 9, true? It creates a fraction. That's fine. What's great about 4? It's perfect square. 9, perfect square. So I can rewrite those as perfect squares. And I'll show you what I'm talking about in just a second. This becomes 4 over 9 x squared. All I did was factor out. That's the first step. Okay, now, what's the square root of 9? Okay, so that I can bring that out, right? So what does that make that in front of this entire fraction? What's it called? I heard it. It's a coefficient. What do we do with coefficients and integrals? Kick them all the way out to the front. So what's my new coefficient going to be? It is. It's a 1/3. So I have 1/3 times the integral. I still have this 1 up here. So now in here, I have the square root. I've got my 1. That's what I wanted. Now here, I need to rewrite this as a quantity squared. What's it going to be? Yes. It's 2 over 3. Excuse me, I forgot my x. 2 over 3 x, the quantity squared, and this is still dx. So do you remember that 5x? We made the u sub for that. So that's what we're going to do here. We're going to say...
2 over 3x?
Yes. Thank you. U is equal to 2/3 x. That's this right here. I'm going to highlight it in green. So now what I've got is 1/3 times the integral of 1 over the square root of 1 minus. We made this u, so now this is u squared. What's the only thing I need to get rid of? I need that dx to be gone. Take the derivative here. Du is equal to 2/3 dx. What do I do? Yep. 3/2 du is equal to dx. So now I put the 3/2 out here. and du is here. So we had to do a lot of manipulation to get this to look like what I want, but all of it was algebraically possible. I did not do anything that was against the rules. So now when you look at this, the integral, I'll move my hand in just a second, of 1 over the square root of 1 minus u squared du, if you go back to that page, it's inverse sine. So now what you have is 1/2 inverse sine of u plus c. Substitute back in. Now here's the issue. You are not going to know this unless you've seen it, so it does take practice. Okay, so this is an example of inverse sine because it had a radical. Now we want inverse tangent even though you've already had one. So let's look here in B. So I know I don't have a 1 in the top, but if I could get this to be a 1, okay, what would I have to factor out? Yeah, a 4. That means I need to divide the denominator by 4. So I'm really pulling out a what? 1/4. Perfect. So we have 1/4 times the integral of e to the x over 1 plus e to the 2x over 4, and then I have a dx here. Okay, is 4 a perfect square? Okay. Think before you answer. E to the 2x, is it a perfect square? It is. Hang on. Think about it. When your base is the same and you're multiplying, what do you do to your exponents? You add. So if you have, just like when I say a perfect square, it's x times x is x squared. You're adding, right? 1 plus 1. So e to the x times e to the x, how many x's do you have in the exponent? 2. So I can rewrite this. So you have 1/4 times the integral of e to the x over 1 plus e to the x over what? 2, quantity squared, dx. Okay, what's my u sub? Perfect. U is equal to e to the x. Can I say times 1/2? Okay, this is why. What do I want to get rid of? What do I want to get rid of? If I make this my u, not just dx, e to the x dx, right? So you have 1/4 times the integral. You have 1 plus u squared in the bottom. I've got to get rid of these two things. So if this is a 1/2, the derivative of u is du. What's the derivative of e to the x? E to the x dx. So here's your 1/2, e to the x dx. Move this over here. So you have 2 du is equal to e to the x dx. So where does this 2 go? On the outside with the 1/4. So it's 2 times. Then I've got 1, and I'll put my du here. What is the integral of 1 over 1 plus u squared? Du. Inverse tangent. So what we have is 1/2 inverse tangent. Can I make my direct substitution of u? You can either write it as 1/2 e to the x or just e to the x over 2 plus c. It takes practice, though. It takes practice. So Gabe and I got into a discussion, why don't we do this or why can't we do that, like some of our old rules. I want everyone to look on the bottom here. Okay? Let's look right here. Look at all 4 of these problems. I'm squeezing them on the screen. So, do they all look similar? They're not identical, but they look similar, yes or no? Yeah. I've got a 25 and a 9x squared almost everywhere. So I picked the hard ones first and the easy ones last because your brains are just about shot, if not already. Okay, so we're going to still get to those hard ones and then we'll be able to do the easy ones quick. So Gabe and I had a discussion and I said, if I make a direct u sub right now, okay, with that first one, which term or terms do you think would be your direct u sub? We're just going to test it out. Just what do you think? Yes, sir?
9x squared.
Just 9x squared? Then I'd have to get rid of the 25, right? Okay. What about the whole thing? 25 plus 9x squared. If I said that that was u, that means I'd have a u in the bottom. Okay, that's fine. We can deal with that. But then what do I need to get rid of? X dx. So let's think about this. So if we say u is equal to 25 plus 9x squared, that means when I take the derivative, the 25 becomes 0, right? And what is the derivative of 9x squared? 18x dx. Okay, does the 18 bother me? It's just a coefficient. All right, so x dx. Do I have an x dx left? Okay, so direct substitution is going to work here. So do you see how sometimes you have to do a little bit of thought? Just a little bit, like what's going to happen? So we're going to make a direct substitution. We're going to say u is equal to 25 plus 9x squared. So what this now gives me is the integral of something over u. Okay, that's fine. I need to get rid of x dx. So you guys, we talked it through. Du is equal to 18x dx. That's not a problem because we're going to divide by 18. So you have 1 over 18 du is equal to x dx. Does that work? Yeah, okay. So the 1 over 18 goes here. And what can I put in the top? Do I have to put du there? No, we can put a 1 here and a du here. Okay. Bless you. You got to think. It's that list at the bottom of the page. What is the integral of 1 over u, or 1 over x, or 1 over y? The natural log. Nice. So what we have is 1 over 18 times the natural log of the absolute value of u plus c. Okay, make your substitution. 1 over 18, natural log, absolute value of 25 plus 9x squared plus c. Okay, so that one wasn't so bad. Agree? Okay. Now, as you're finishing up, take a look. These look seriously almost identical. What's the only difference? Yeah, there's no x in the numerator of the second one. So that means if I try to do this again, which first of all, why would I? Because it would be the identical problem. I'm not going to redo. Okay? I can't do this. So this is actually one of the inverse trig functions. Which one do you think it is? Yeah. But in order for this to be an inverse tangent, because there's no radical, I need that 25 to be a what? It needs to be a 1. How do I make it a 1? Yeah. Factor out a 25. Can I bring that 25 all the way to the outside? Yeah. Okay. So this is 1 over 25 times the integral. 1 in the numerator, because I'm going to put the dx over here. So what's here? A 1 plus, what's here? 9x squared over 25? Okay. How's that going to help me?
Perfect squares.
Perfect squares. Okay. So now you've got 1 over 25 times the integral of 1 over 1 plus, I want to write this as a perfect square quantity. What is it? Perfect. 3x over 5 or 3/5, it doesn't matter, right? 3/5 x. Okay, now what do I do? U sub. So what is u? Yep, 3x over 5 or 3/5 x. So now we have 1 over 25 times the integral of 1 over 1 plus u squared. What needs to go? What's the only thing that's left? The dx. Okay, so you have du is equal to 3/5 dx. Help me. 5/3, yep. So the 5/3 will go here, and the du goes here. Okay, what's the integral of 1 over 1 plus u squared?
Inverse tangent.
Yep. Okay, so let's reduce this. What is this, 1 over 15? Inverse tangent of u plus c. Make your substitution. Again, it takes practice, though, and I will tell you right now, you have a problem in your homework that you don't have a perfect square. I want to see what you can do with it. Okay? All right. Help. Think back to the last lesson. Do we have a quotient rule? No. What did we do when we didn't have a quotient rule? I heard a couple different things. I heard it. Just divide. What's 25 over x? How can I write that? Do we want to write it as to the x to the negative 1 though? Because we just went through. What's it going to be? It's a natural log once we integrate, right? This right here. So this is the integral of 25 over x plus 9x squared over x dx. I'm just writing it out so you can see what I'm doing. This I can divide totally. This is 25 times 1 over x. What's the integral of 1 over x? Yeah. Okay. So this is the integral of 25. I'm just going to write it of 1 over x dx plus the integral, what is that, just 9x dx? This is what we're thinking in our brain. We don't always have to write it, but it's what we're thinking. So you told me the integral of 1 over x dx is the natural log of the absolute value of x. So this is 25 natural log absolute value of x plus, help, oh my gosh. Do I have to worry about the 9? Not really, but what is the integral of x? 1/2 x squared. So can I write this? Okay, so far, look at all your answers. They don't look the same at all, do they? None of them. Nope. Okay, here's the easiest one of all. How do I tackle this problem? It's a sum. You literally just take the integral of each term, right? Even if there were 15 terms, you just take the integral of each one. So what is the integral of 25? 25x plus, what is the integral of 9x squared? 3x cubed, and don't forget your plus c. So do you see how I said I went all the way to the easiest one? Questions?